I welcome everyone to this video. We are looking here at cross-sectional area using a square pyramid. The base of that pyramid being a square. Now what do we mean with the cross-sectional area? If I were to draw a slice and I bring it out and I pluck out the slice, I make the face of that slice parallel to us, we're looking here at a square. That right there is my cross-sectional area I have to calculate of a slice. It has a certain side, and we're determining the area of this. As you will see it to be the area of that slice. Any slice you draw from a square pyramid, no matter where from the base to the apex, it will always be a square. Obviously the slices and the areas of cross sections you're making from the base are larger. Towards the apex they are smaller until they disappear altogether. And this right here is the apex of your pyramid. Now keep in mind one fact. We're looking here at a pyramid with a base B. It has a certain height and h. At its maximum, the cross-sectional slice can be b square, because that would represent the base of the pyramid where the pyramid is most broad. At its minimum, the area can be 0 right here at the point, the tip of the apex of that pyramid where you have a point. In essence, you're looking at a specific point, the apex of that. There will be no dimension and the area will be 0. So the cross-sectional areas will be somewhere between b square, here's my s square, and it'll be right here, larger than the apex but smaller certainly than the base of that pyramid. And you are going to determine this. Obviously we can't just do s square, it would be incorrect. Why? Because it doesn't account for the convergence of your pyramid from the base to the apex. Your cross-sectional slices are broader at the base, they're smaller and narrower towards the top, so you have to account for that convergence. How can we account for that convergence? It's a simple ratio you have to keep in mind. If I were to pluck out a cross-sectional face of this pyramid, it would have a triangular representation and it would represent the base, the complete base as you see over here, and a complete height. I'm looking at a certain slice and I'm giving it a dimension s like you see here, and it is from the tip or the apex of the pyramid x units down. Keep in mind, we're solving here for s. You're doing here a complete height divided by complete base is equal to a partial height divided by a partial base dimension, which is s. You solve for s. S here is equal to xb over h. We bring it in. xb over h and xb over h. So now suddenly we've determined that any cross-sectional slice, it has a representation by means of this ratio. Therefore s square is equal to x square b square over h square. Now if you do an area calculation using that, it's correct, because that b over h ratio along with the x captures the convergence from the base to the apex, the slices being broad here and then they're narrowing out and becoming smaller towards the tip of that or the apex of that pyramid. Now what we can do is just bring it all together in a question. Keep in mind this specific point, this value x was measured from your apex down to your slice, so you have to remember that. Let's look over here at a calculation. We'll close the video out with that. We're calculating the area of a cross-sectional slice of this square pyramid if the base of that pyramid was 60 units. We're not worrying here about actual units, centimeters, meters, feet, inches, whatever. The height of that pyramid is 100 and your slice was cut or made 30 units from the base. Remember what I told you here in my formula, my ratio, the slice was cut here from the apex, but I'm here looking at it from the base, so you have to adjust it. If it's 30 units on the base, then it means it's 70 units from the apex. Therefore x here is going to be what? It's going to be 100 minus 30, which is equal to 70. So you have to remember that. How you define your ratio, you have to keep that in mind. 30 units from the base or 70 units from the apex. Now all you have to do is put everything into that formula. What do I have? I have my s square here is equal to a 70 square times. We have a b square, which is a 60 square, and then we have here a height square, which is going to be 100 square. Just for perspective, let me show you something. Remember what I told you at the very beginning, the cross-sectional area will be larger than the area at the tip of the apex will be smaller than the base area, which is the largest. So we're going to have a value which will be somewhere in between. For this specific example, what would have been the base? The b square would have been what? 60 times 60. I'm doing this as a comparison only. The b square would have been 60 square, which is what? 3,600. It would have been 3,600 units squared. Now let's run this cross-sectional slice area. It should be smaller than this, and it will be. Let's do the calculation. We have 70 square times 60 square divided by 100 square, and our answer is 1764 units square, and it will be correct. 1764 units square. So it makes sense. A base of a square pyramid, 60 units, height 100 units, slice 30 units from the base or 70 units from the apex. That cross-sectional slice, assuming it was this, it would have an area 1764 units square, and it would be correct. But that same base of that pyramid would have a much larger, or the maximum possible slice area, because indeed the base represents a slice. If you were to pluck it out, it would be 3600 units square. The apex of that pyramid will be 0 units square, and it is a correct answer. That's it for this video. Thank you for joining me.